Hi, it's someone on the math. Easy solution. We're going to discuss some more trigonometry derivatives and basically look at an example which using the sine x over x limit property which I showed in my earlier video. Basically, well, this derivative is more of a limit, but I'll show you how you could use derivatives in a bit. Basically, if you have limit x approach 0 of sine 7x over 4x, this one here, if you plug in 0 inside, you'll get a 0 over 0. So this is undefined, so you cannot plug it in, you can solve it. But there's two ways of actually solving this. You could use this property, which I showed in my earlier video, basically limit as x approaches 0 of sine x over x is equal to 1. So make sure to watch a proof for that. So we could use this method, and the other way is applying L'Hopital's rule right here. Yeah, but for some reason in a lot of my earlier calculus course, they wouldn't let me. Teacher wouldn't accept using this method. But I really liked it. Basically, you could take derivatives of the top and bottom if you have an indeterminate form like this, or an infinity over infinity, etc. So basically, we'll try this method first, and then this one here second. Here, I just want to show both. This to help you basically learn more about these limits and derivatives. Basically, if you look at this one here, this isn't in the form of this, but you could write it in the form of it. Basically, first what you could do is multiply the top and bottom by 7. So we'll get limit x approaches 0, 7 over 7 sine 7x over 4x. Just rearrange this, put the 7 in front, so we will get equals limit as x approaches 0 of 7 times sine 7x over, well, 7x, and let's just flip it around, so 4. So as you can see, this part here is actually the same thing as sine x over x, and you could either just look at it and agree with that, or let's say let a is equal to, let's put it divided by here. Let's say let a equals 2 7x right here. So then basically, as not the a sign, as x approaches 0, if this is going towards 0, a is also going to 0. So a is also going to 0, so that's the only thing we change. So limit as a approaches 0 of, it's be the same thing, 7 over 4, now put 7x, so this is going to be sine a over a right here. So once again, this 7 in front doesn't change anything, so we could apply the same thing, and this will just be equal to, well, this is going to be equal to, put the 7 out of 4 out of there, limit as, well, we could either put the a or just go back to the x. So x approaches 7, the sine 7x over 7x. So this is the exact same thing as this, and this would equal to 1. So we'll just have equals to 7 over 4 times by 1 right here equals 7 over 4. So this is an easy way of applying the rule. I just wanted to do this extra step, letting a equals to that, just to show you that's the same thing. So equals to this, but you can also use L'Hopital's rule, and I like using L'Hopital's rule, but I just still don't understand why in my first year of calculus they wouldn't accept the marks for it. But anyways, if you use that method right now, since it's going to be 0 over 0, which is in the determinant form, as you can see in my earlier video, we could just apply the derivative of the top and bottom. So this is going to equal to d over dx of sine 7x, all divided by d over dx, or the derivative of the bottom, which is, what is it, 4x, I think, yeah. So 4x. So we just apply the derivative. This equals to limit as x approaches 0 of, this is sine 7x, this will be cosine of 7x, and then using chain rule puts a 7 in front right here. So that, and then divided by, well, derivative 4x, just going to be 4. So now we can just plug this in right here, because if we plug in 0 inside cos, so cos of 0 is equal to 1. So we'll get, basically, the answer is going to equal to 7 over 4 times cosine of 0. This is just 1, so we'll equal to 7 over 4 times 1, or equals 7 over 4. So as you can see, the L'Hopital's rule is much quicker if you memorize that, but it's I like it a lot. You just take the derivative of the top and bottom if you have a 0 over 0 or an infinity over infinity. Or you could also apply this quick method, so it's pretty quick and easy. just multiply the top and bottom by 7, etc., and you get in the formula like that. Well, anyways, that's all for today. Hope you learned from this pretty useful example. You get this one showed a lot on basically limits and derivatives, how to solve stuff like this by making it look like something we already know, or applying a L'Hopital's rule, which is a really powerful rule for finding limits. Anyways, that's all for today. Hope you learned from this, and like always, you can download these exact notes in a Dropbox link below, and stay tuned for another math easy solution.